Hello class, this is Tim Tomlanovich. This is Learning Plan 1 in Cemented Eggs. So I'm using WebEx to record it, so I don't know how clear it's going to be on your end. Okay, so with that, let's talk about, we're classifying aggregate properties using concrete and asphalt mixtures. So in this lesson, we're going to identify the origin of aggregates, and we're going to define the aggregate types. Okay. Again, as you've seen this before, so a lot of this information that I'm showing you will be on a quiz or an exam. Some or all or none. You never know. Okay. Again, we talked about this in lab. What is an aggregate? Remember, it's a granular material such as sand, gravel, crushed stone, or blast furnace slag used with a cementing medium to form hydraulic cement, concrete, or mortar. So I just wanted to just refresh your memory. And where does aggregate come from? Remember, igneous bedrock, sedimentary bedrock, and metamorphic bedrock, just to review. Okay, so just to go a little bit more on the rock cycle, we kind of look here. Basically, igneous rocks form, they push up, they get eroded, they turn into sedimentary rocks, they get buried deeper, and metamorphism, I can't say that word, metamorphic rocks form, and then it just goes around. It's kind of like the weather cycle, but this takes billions of years. Rocks actually just reform. Again, here's the bedrock of Wisconsin. We're over here. Our bedrock is dolomite. So dolomite and shale and dolomite. So up in Dork, there's a lot of quarries right over in here, Manitowoc. So Highway 43 runs right about there. Okay, again, coarse aggregate, retained on a number 4, 4.75 millimeter. Fine aggregate passes the number 4 and retained on the number 200, which is 0.075 millimeters. You need to know those. All right, so now it's going to go into further detail. So we have gravel, coarse aggregate resulting from natural disintegration and abrasion of bedrock or processing of weakly bound conglomerate, mostly rounded faces. This is what we have around Wisconsin because of our glaciers. Okay. We had a big sheet of ice that pushed down, and then over when the glaciers retreated and advanced and retreated, and the glaciers melted, the bedrock was ripped apart, and then the pieces of bedrock were transported down outwash streams, and then over time, over millions and millions of years, they got rounded. So gravel is from natural bedrock, or bound up conglomerate, which is okay, and then just remember rounded faces, okay. Crushed gravel, the product resulting from the use of mechanical devices to break gravel into smaller fragments. Okay, so when you see crushed, when you hear the word crushed, they will be taking natural gravel, rounded gravel, and they'll run it through a crusher so we can get an angular face. Okay, all right, so we got gravel. Remember, it's natural from glaciers, rounded. And then crushed gravel, they're taking a natural gravel and running it through a crusher to get angular faces. And I'll explain why later, why we want those angular faces. We have crushed stone. So basically, crushed stone is similar to crushed gravel, except crushed stone is when they blast bedrock out of the quarry, right? They'll take these big boulders, huge, and then they'll crush it. Okay, bedrock boulders, cobbles into smaller fragments. Again, it's angular, crushed stone. So think of stone as big, massive pieces of bedrock. Natural sand, fine aggregate. Again, fine aggregate passes the number 4 sieve, retained on the number 200 sieve, is resulting from natural disintegration of abrasion of bedrock or processing of completely friable sandstone, mostly rounded faces. Erosion. Erosion and transportation by the glaciers causes natural sand. Okay? It has nice natural sand. Think about it rolling down the stream. Rounded faces, natural sand. Natural gravel, rounded faces. Natural sand is rounded faces. Natural sand is fine aggregate. Natural gravel is coarse aggregate. Okay. Manufactured sand, fine aggregate produced from crushing bedrock gravel, iron blast, furnace slag, or hydraulic cement concrete. So this is where they'll run it through a crusher and sieve it to have it all pass the number 200 sieve and retain on, or all pass the number 4 sieve and retain under 200 sieve. Okay, it could be angular, it could be rounded, depending on how it is, depending on the original state of the bedrock. All right, bank gravel, pit run. Gravel found in natural deposits, usually more or less intermixed with fine material such as sand or clay, or a combination thereof. Gravelly clay, gravelly sand, clay gravel, sandy gravel indicate the varying proportions of materials in the mixture. So if you look here, okay, remember the glaciers came down from Canada. They basically, it was like a big bulldozer, and it just pushed. It grabbed the bedrock and it ripped the bedrock up in pieces, and it just kept pushing and grabbing all the sand and gravel, and it just kept rolling up in front of the glacier or underneath the glacier. And all of a sudden it stops. The glacier stops, okay? And all of a sudden it retreats. So basically what happens is we get this pit run, bank gravel pit run, okay? All right. So then over time, when the glacier melts, streams form, and it'll actually grab this pit run and it'll start transporting it down the stream, and it'll make it, it'll start sorting out in different sizes. So we'll get natural sand and natural gravel, and we'll get rounded faces. So if you notice here, we got rounded faces. I mean, literally the glacier, because it's been traveling under the glaciers for hundreds and hundreds of miles and being ground up, it's going to have rounded faces. It's not going to have natural angular faces. Very, very rare you're going to see angular faces because of the glaciers just grinding it up. Okay. All right. Fines. So we know what coarse aggregate is. Aggregate retained on a number 4 sieve, which is 4.75 millimeters. We have fine aggregate, which passes the number 4 sieve, retained on the number 200 sieve. And now we have something called fines. All right. Fines pass the number 200 sieve, which is 0.075 millimeter. Don't confuse this with fine aggregate. Fines are silt and clay. That's kind of the dirty material that we don't want stuck to our aggregates. Otherwise, the cement paste will stick to the fines, and then it'll just, the concrete will fall apart. Okay, so we have fines passing the number 200 sieves. So we have three different kinds. We got coarse aggregate, fine aggregate, and fines. Okay, so just understand what's happening with those. And that concludes our presentation for Learning Plan 1.